one-dimensional motion. We are going to start with, and then we'll move into two-dimensional and talk a little bit about three-dimensional motion. We can think about motion with regard to points. So here we have the points x, y, z if we're three dimensions, but mostly we'll just worry about our x and y coordinates. If we're talking about moving from, say, the point 314 to the point 914, if we were to graph that, that's simply going to be, well, the y is constant. So it's going to be motion in the horizontal direction. So that means you went from 3 to 9, so you moved a distance of 6. Vertical motion would be the same idea. You have a constant x. You went from 14 to 25, so your distance is 11. Typically what we're going to talk about is we're going to talk about the idea of a change in position. Generically, I will look at it usually with regard to a delta x. I like to use the subscripts F for final and I for initial. In other words, I begin at the initial and I end at the final position. Distance is how far we traveled. Moved. Displacement is how far and which direction. When we talk about the rate of change, the time rate of change of position, and oftentimes you will hear this referred to as a time rate. Anytime you're dividing by t, that could be a time rate, not a time rad. Alright, so time rate of change of position if we have a large amount of time, and that is an average. As our time interval goes to 0, then it becomes instantaneous. And I think I spelled that correctly. When we're talking about how fast, we're just talking about speed. And how fast and in what direction, then we have what we call velocity. The time rate of change of speed or velocity is acceleration. Hence the A. Names. Now, we use the term acceleration both with and without a direction. And we'll clarify that as we move on a little bit more. Everything that we work with in this course is going to be a situation of what we call UAM. That is uniformly accelerated motion. So with UAM, what we have is a constant rate of change of velocity or speed versus time. Now, we may have a situation where it's uniformly accelerated motion over a certain interval. And so we may have a situation where we have a uniform acceleration over this interval, and then a uniform acceleration over this interval, and so on. But everything will be a uniformly accelerated motion situation, UAM. So let's say we have a cheetah that can accelerate from rest to a speed of 30 meters per second in 7 seconds. What is the acceleration? Okay, so a change in speed or a change in velocity per time is what we defined as acceleration. It's our VF minus our VI over t. Our initial speed is at rest, so that's our VI. Our final is 30 meters per second, so there's our VF. Our time is 7 seconds, so we have 30 minus 0 over 7. which is equal to 30/7. 4 2/7. If you want to look at it as a fraction. And that's going to give an exact answer. If you are looking at it as a decimal value, I just wanted to double check myself in my head. Now that's going to be 4.2857 blah blah blah. Now let's look at our significant digits. 3, 3, and rest is defined as 0, so that's 4.29 meters per second. Again, you'll notice that I do often use the non-standard SEC abbreviation for second. Well, per second gives us, in fact, meters per second squared. Oftentimes, you will see it written properly as meters per s squared. A football quarterback runs 15 meters straight down the field in 2.5 seconds. He's then hit and pushed 3 meters straight backward in 1.75 seconds. Breaks the tackle and runs straight forward another 21 meters in 5.2 seconds. Calculate his average velocity for each of the 3 intervals, and then for the entire motion. Okay, so each of the 3 intervals, I1, that's our first interval. Make it a colon instead of an equals. His average speed is what? Well, it's a distance per time, or a delta x per time, or xf minus xi per time. Either way you look at it, that's 15 meters in 2.5 seconds. And 15 divided by 2.5 is 600 meters per second. For the second interval, now notice I said velocity. Velocity depends on direction. I'm going to assume that he started out running to the right, so this gets to be a positive. Now went backward 3 meters 1.75 seconds. So my d, my delta x, is in fact a negative 3 over 1.75. So negative 3 divided by 1.75 is a negative 1.714. We have, in each case, we have 3 significant digits to this piece. So negative 1.71 meters per second. The third interval, 21 meters in 5.2 seconds. Back forward again. 21 divided by 5.2. 4.04 meters per second. Now, if you look at the entire motion, and I'm going to write that as I1 through 3. We have a distance of 15 minus 3 plus 21 over 2.5 plus 1.75 plus 5.2. So we have, for a total distance for the run, 12 and 21 makes 33 meters in, let me add these up, I don't want to trust myself to do it in my head. .45 seconds. Or a total of 3.49 meters per second. Now notice all of these are 3 significant digits, so all of our answers should be 3 significant digits.